Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of definite integration. And if I talk about the question that is given to us here, the question asks us to find the value of an expression. And the expression given to us here is e raised to minus pi by 4 plus limits from 0 to pi by 4 e raised to minus x tan raised to 50x dx. And the denominator given is 0 to pi by 4 again, but the expression given is e raised to minus x tan raised to 49x plus tan raised to 51x dx. So we need to find the value of this entire expression, and the options given are 51, 50, 25, 49. So we need to figure out which one is the correct answer for the question given to us. So if I solve for this expression that is given first, I can write that entire expression as e raised to minus pi by 4 plus limits from 0 to pi by 4 e raised to minus x tan raised to 50x dx over 0 to pi by 4 e raised to minus x tan raised to 49x dx plus 0 to pi by 4 e raised to minus x tan raised to 51x. So you have this entire expansion of the expression given. Now, when I have this entire expansion given, I can write that as, if you see, all of these three integrals have the same limits from 0 to pi by 4. All of the three also have e raised to minus x with them. Only difference I can see here is the power which is of the tan x. So here you have power as 50, here you have power as 49, and the other you have the power as 51. So I can write let I of n is from the limit 0 to pi by 4 e raised to minus x tan raised to n x dx. So I'm writing that as in. So your entire value of the expression turns out to become e raised to minus pi by 4 plus I of 50 over I of 49 plus I of 51. So once I get these values of I of 50, I of 49, I of 51, I'll substitute that and get the answer for the question. So let's solve for in now. So in, it's 0 to pi by 4 e raised to minus x and tan x to the power n dx. So I have the product of two functions here. So if I use the idea of integral u into v dx, I can write that as u integral v dx minus the integral of derivative of u and integral of v dx. So if I use that idea to understand which is u and which is v, I'll use the idea of Lie, which is logarithmic, inverse, algebraic, trigonometric, and exponential. So I understand this is exponential, I understand this is trigonometric, and the first which comes is u and the other is v. So I get this is u and I get this is v. Once I have this as u and v here, if I solve for that, I get that as tan raised to nx integral e raised to minus x dx minus bigger integral derivative of tan raised to nx integral e raised to minus x dx the whole dx. Now if I further solve it, I get I of n is equal to, because this entire integral is I of n, so I write that as I of n. Further I write that as tan raised to n x. Integral of e raised to minus x is minus e raised to minus x. So you have the solution here for the first part. So you apply the limits also, 0 to pi by 4 plus or minus big integral. So I write that as minus a bigger integral derivative of tan raised to nx. So tan x raised to n. So n into tan raised to n minus 1 x. into derivative of tan x, which is sec square x, multiplied with integral of e raised to minus x, which is minus e raised to minus x dx. So you get this I of n as, if I apply the limits, I get this as minus e raised to minus pi by 4 tan raised to n pi by 4 and minus of, if I apply 0, I get minus e raised to minus 0 and tan raised to n of 0 minus integral n tan raised to n minus 1 x sec square x. I can write that as 1 plus tan square x, and here I have minus e raised to minus x dx. Limits are from 0 to pi by 4. Now further, if I solve for in, I get that as in is equal to minus e raised to minus pi by 4, and this tan of pi by 4 is always 1, so 1 raised to n is 1, so you get minus e raised to minus pi by 4, and this entire thing is 0, so you have it as it is. And this, if I try to solve, it becomes minus of minus, so plus integral 0 to pi by 4 e raised to minus x, and n also is present, so n, and you have tan raised to n minus 1 x multiplied with 1 plus tan square x. So if I multiply it inside, I get that as tan raised to n minus 1 x plus, this becomes n minus 1 and plus 2, so n plus 1. So you have this entire thing, and if I further solve it, I get minus of e raised to minus pi by 4 plus limits n 0 to pi by 4 e raised to minus x tan raised to n minus 1 x dx plus 0 to pi by 4 e raised to minus x tan raised to n plus 1 x. So I got this understanding here. Now let's solve for that. I of n, you get that as minus e raised to minus pi by 4 plus this, if I solve for, I get n e raised to minus x and tan raised to n minus 1 x dx with limits of 0 to pi by 4. I already know I of n was 0 to pi by 4 e raised to minus x. Only difference was it was tan x raised to n. Here instead of tan x raised to n, we have n minus 1. So I can write that as I of n minus 1 plus, here also if you see, you have same limits, you have e raised to minus x. The only difference is the power of tan x, that is n plus 1. So you write that as I of n plus 1. So you get this entire thing, that I of n is minus e raised to minus pi by 4 plus n times I of n minus 1 plus I of n plus 1. So if I want to write I of 50 with this, I can write that as minus e raised to minus pi by 4 plus n I of 50 minus 1, that is 49, plus I of 50 plus 1, that is 50. So you get this entire thing as I of 50. And if I see the answer, I have the question as this. So if I put my question, which was e raised to minus pi by 4 plus I of 50, denominator it is I of 51 plus I of 40. So you have this entire thing as your expression. And if I have that entire expression, instead of I of 50, if I put what I have got for, I have got e raised to minus pi by 4 minus e raised to minus pi by 4 plus n times n. In this case, actually, I should have substituted that. N in this case is 50. So I should write that as 50. So 50 I of 49 plus I of 51. So this and this gets cancelled and you are left with I of 51 plus I of. So if I see I have 50 times that same term here, so I can cancel my term entirely, and with that I get the answer as 50. So if you see the answer choice that matches with the question here, that answer has to be option. So B becomes the correct answer for the question given to us. I hope you have understood how to solve this type of questions which deals with the ideas of finding the values of such expressions which deals with definite integration. So we needed to solve for u and v as the product rule of the integral. Once we solved for that using Lie-it, I got that understanding and I further simplified it and cancelled my numerator and denominator. That gives me the answer as option. So B becomes the correct answer for the question given to us. I hope you have understood how to solve this type of questions. I'll see you again tomorrow with some other question from some other topic. And we are going to continue a series of questions on 11th, 12th as well as JEE mains. So stay tuned for more videos to roll out. Also, if you are enjoying these videos which we are solving every day, please do like the videos. Also subscribe to my channel and do share these videos with your friends who are involved in the preparation of questions on JEE. So they can also take the benefit from these questions which we are solving on everyday basis. Thank you.